Today also we will solve a problem. Okay. The third problem is a diesel engine power plant has 700 kilowatt, 700 kilowatt. Okay, it has one unit of 700 kilowatt and two units. Okay, one unit of 700 kilowatt. What happened? And two units of 500 kilowatt. I will turn off the annotation first. Okay, 500 kilowatt generating units. The fuel consumption is 0.28 kilogram per kWh. Means what? To generate 1 kWh of electrical energy, 0.28 kilogram of fuel should be burned. And the calorific value of the fuel is 10,200 kilocalorie per kilogram. Means what? By burning 1 kilogram of fuel, 10,200 kilocalorie of heat will be generated. Estimate the fuel oil required for a month of 30 days. Second, they are asked for overall efficiency and the plant capacity factor is 40%. Plant capacity factor is 40%. Okay. So we will solve the problem. First, they ask for what? Total fuel consumption in 30 days. In 30 days. Okay. And for that, we can use this formula. The specific fuel consumption. Sorry. Specific fuel consumption is equal to, they have given 0.28 kilogram per kWh. Okay, means what? If 1 kWh of energy required, then 0.28 kilogram of fuel should be burned. Then suppose in 30 days y kilogram of fuel is burned. Okay, y kilogram of fuel is burned, and due to that x kWh of energy generated. Okay, means what? X kWh is a energy generated. Please mute everyone, please mute yourself, or I will mute. 1 minute. Mute all. Okay. So X is nothing but what? Energy generated in 30 days. Okay, energy generated in 30 days. And Y kilogram is nothing but what? Fuel consumption in 30 days. Okay, so to calculate Y, that is fuel consumption in 30 days, we have to calculate total energy generated in 30 days. Okay, and for that the information of plant capacity factor can be used. Okay, we will see. First we have to calculate the what is the plant capacity, total plant capacity. Okay, then we will use plant capacity factor to calculate energy generated. Okay, we will see how. The energy generated, okay, this is the maximum energy generated. Okay, maximum energy generated, okay, in 30 days. Okay. Maximum energy generated when the the power generated by the units will be maximum. Okay, means what, they will utilize their full capacity. Okay, they are given one unit of 700 kilowatt and two units of 500 kilowatt. Okay, means what, at any time they should develop power equal to 700 and two units will generate power equal to 1500. Okay, so it is equal to plant capacity, okay, full capacity into number of hours in 30 days. Okay, so plant capacity means power. We can see that plant capacity is the maximum power. Okay, there is a one unit of 700 kilowatt and two units of 500 kilowatt. Okay, into number of hours in a month is equal to 30 days into 24 hours. So it is equal to 1700 into 30 into 24. Okay, it will be equal to 17 into 3 into 24, 1224 into these two zeros of 1700 and one zero of 30 is what, into 10 raised to 3 kWh. Why kWh? Because the plant capacity we have considered the total power generated. Obviously it is in kW and we have calculated number of hours in 30 days and it is equal to, its unit will be HR or H. Okay, so the total unit will be kW into H, that is kWh. Okay. This is what we have calculated maximum energy generated in 30 days. Okay, but they have given the plant capacity factor. Okay, and its formula is plant capacity factor is equal to actual energy generated. In first chapter we have seen these formulas, divided by maximum energy generated. Maximum energy that can be generated. Okay, plant capacity factor they have given equal to 40%, that is 0.4. It is equal to the actual energy generated is unknown quantity and maximum energy generated we have calculated is equal to 12,024 into 10 raised to 3. Okay, therefore actual energy generated will be equal to 0.4 into 12,024 into 10 raised to 3. It is equal to 12,024 into 0.4, 489.6, 489.6 into 10 raised to 3 kWh. Okay, means what, if the units are generating the power equal to their full capacity, then we will get maximum energy which is equal to 1224 into 10 raised to 3 kWh. But their plant capacity factor is 40%. Means what? Only 40% of total capacity is generated. Okay, means what? We have to multiply plant capacity with the maximum energy generated to get actual energy generated. Okay, which is equal to 489.6 into 10 raised to 3. Okay, so the fuel oil consumption in a month, okay, we can calculate it now. For generating 1 kWh, we require 0.28 kilogram of fuel. Then to generate X kWh, Y kilogram of fuel is required. Okay, so Y kilogram we have said it is a fuel consumption in 30 days, and X kWh is the actual energy generated in 30 days. Okay, in 30 days. So now we have X value of X. Okay, so 0.28 divided by 1 into X is equal to Y. Okay, therefore Y is equal to 0.28 into 489.6 into 10 raised to 3, which is equal to into 0.28, 137.088, 137.088 into 10 raised to 3. Okay, which is equal to 137088 kilogram. Okay, means what? This amount of fuel should be consumed in a month to generate 489.6 into 10 raised to 3 kWh of energy. Okay, now we have fuel consumption, that is first part is solved. Y is nothing but what? Fuel consumption in 30 days. In second part, they have asked for overall efficiency. Okay, eta overall, which is equal to output by input. Okay, output is nothing but what? Energy, actual energy generated, sorry, one minute, actual energy generated divided by heat of combustion. Input is heat of combustion of fuel. Okay, so output we have, output is equal to 489.6 into 10 raised to 3, which is equal to 489,600. Okay, and it is in kWh. We have to convert it into kilocalorie because the denominator is also kilocalorie, which is equal to 489,600 into 860 kilocalorie. Okay, we know that 1 kWh is equivalent to 860 kilocalorie. Okay, similarly, input we have calculated is equal to 137,088 this amount of fuel is burned. Okay, this is the mass of fuel. Okay, it has to be multiplied by with calorific value. Calorific value, okay, which is given in kilogram per kilocalorie per kilogram. Okay, so is equal to 1,37,088 kilogram into calorific value they have given equal to 10,200 kilocalorie per kilogram. Okay, kilogram will be get cancelled and we will have input energy. Okay, so now we can calculate overall efficiency. Eta overall will be equal to output by input. Output is equal to 489,600 into 860 divided by input is equal to 1,37088 into 10,200. Okay, we can solve it, which is equal to I will do calculation here. Which is equal to 0.30. Okay, means what? It has an overall efficiency of 30%. Okay, do you get it? Problem का solve केलं ते पेपरला आतापर्यंत पहिल्या 3 चॅप्टरवर काही प्रॉब्लेम पडलेले नाही. चौथ्या चॅप्टर म्हणजे डिझेलवर पडलेला आहे. आपण नेक्स्ट लेक्चरला पेपरला पडलेला प्रॉब्लेम सॉल्व्ह करूया. मग त्याच्यापूर्वी एक प्रॉब्लेम हायड्रो इलेक्ट्रिक पॉवर प्लांट वरचा एक बुक मध्ये आहे, थोडासा वेगळा आहे, तो जरा बघूया आपण. त्या पद्धतीचा प्रॉब्लेम काय आपण पाहिला नव्हता. ओके, दिस इज द प्रॉब्लेम. हायड्रोइलेक्ट्रिक पॉवर प्लांटचे आपण आय थिंक 4 प्रॉब्लेम सॉल्व्ह केले होते. हा एक थोडासा वेगळ्या पद्धतीचा प्रॉब्लेम आहे, मे बी पेपरला पडेल म्हणून घेऊया. आता काय दिलं बघा त्यांनी. The weekly discharge of typical hydroelectric plant is as under. Okay, day wise discharge they are given. On Sunday the discharge is 500 meter cube per second. On Monday it is 520. On Tuesday 850. On Wednesday 800. On Thursday it is 875. On Friday 900 and on Saturday 546. The plant has an effective head of 15 meter. Effective head of H is equal to 15 meter. Okay, this is the problem on hydroelectric power plant. And overall efficiency of 85%. Okay, if the plant operates on 40% load factor, 40% load factor, then estimate the average daily discharge. Average daily discharge means what? We have to add daily discharges and divided by number of days. Okay, we will get average daily discharge. Okay, in graph, okay, it is shown here. It is equal to 713. Actually, it is drawn after calculation. Pondage required. Okay, means what? Sometimes the runoff or discharge is lower than the average. Okay, for example, in this diagram you can see that the average is 713. Okay, shown by this dotted line. Okay, But on Sunday, Monday, and Saturday, the discharge is lower than the average. Okay, means what? For example, on Sunday, the discharge is lower by this amount, 713 minus 500, which is equal to 230. Okay, so what this amount of discharge we have to provide. Okay, and for that, uh, in some dam, okay, pondage is erected. Okay, pondage actually it is we can say like it is a pond. Okay, it is a pond where uh, water is stored, and when there is a scarcity of water, that water will be used to give extra डिस्चार्ज. ओके, म्हणजे एक पद्धतीचं एक्स्ट्रा एक तलाव तयार केल्यासारखं लेक वगैरे जे असतं तसं फॉर्म केलेलं असतं आर्टिफिशियल. आणि ज्या ज्या दिवशी किंवा ज्या काळात वॉटर फ्लो कमी आहे, ओके, तर त्या ठिकाणी ते पॉन्डेज मधलं जे वॉटर आहे ते वापरलं जाईल. ओके, जेवढ्या प्रमाणात कमी आहे तितक्या तेवढं. Third, they have asked for installed capacity of proposed plant. Installed capacity of proposed plant. Okay, means what maximum power capacity of that plant. Okay, maximum demand. Okay, we can see that a maximum demand. I will show you how a pondage can look like. 1 minute. Okay. Okay. For example, here you can see that how to enlarge it. Okay. Here is a 1 minute. You can see that a Bandila pondage means what? The name of the pondage is a Bandila. आपल्याकडे शिवसागर वगैरे असे नावं असतात. ओके, त्या पद्धतीने नागार्जुन सागर तशा पद्धतीचं हे ऑस्ट्रेलियातलं आहे बँडीला. तर या ठिकाणी तुम्ही बघा म्हणजे जनरेटिंगचे सब वेगवेगळे त्या ठिकाणी स्टेजेस असतात. मग एक पर्टिक्युलर मे बी स्टेज आहे, त्या स्टेजला वॉटर जे आहे त्या इथून एका लेक मधून घेतलेला आहे, या लेक मधून घेतलेला आहे. आय विल टर्न ऑन द एडनोटेशन. ओके, 1 minute. Okay, this is the poundage, and extra a particular stage. Okay, a particular stage of generation is supplied from this lake. Okay, from this lake. Okay, and whenever the level of the lake will be decreased, okay, the runoff or the discharge to the turbine will reduce. Okay, so to overcome that, okay, extra pondage is made. Okay, means what? Whenever the whenever the uh, level will be decreased, this pondage will provide the water required. Okay, like that pondage will work. Okay, now we'll solve the problem. 1 minute. Okay, so first we have to calculate the average daily discharge. Okay, the average daily discharge will be equal to, average means what? Number of quantities divided by the number of events. Okay, like that. For example, in this case, On Sunday, the discharge is 500. On Monday, it is 520. On Tuesday, it is 850. Okay. On Wednesday, it is 800. On Thursday, it is 875. On Friday, it is 900. And on Saturday, it is a 546. Divide by total number of days. Okay. Obviously, 7 days in a week, which is equal to, okay, I will calculate here, 500 plus 520 plus 850 plus 800 plus 875 plus 900 plus 546 equal to, divided by 7. It is equal to 713. Okay, and it is shown in the graph. Okay, first we calculate this number. Okay, obviously it is in meter cube per second, and then we will show it on graph. So first part is solved. On second part, they have asked a pondage required. Means what capacity of pondage is required, okay, to meet the scarcity of water on 3 days of a week. Okay, that is on Sunday, Monday, and Saturday. Okay, on these days, water level is less than the average. It means what? Less than 713. Okay. Second part, on Sunday, Monday, and Saturday, the discharge is less than the average, okay, of 713 meter cube per second. Okay. So first we calculate how much volume is available on these 3 days, and then we will calculate how much extra water we will require. Okay. So volume of water available on these 3 days will be equal to, on Sunday it is 500, on Monday it is 520, and on Saturday it is a 546. Okay, this is the total discharge meter cube per second. Okay, and it is required full day. Okay, it's what, 24 hours. Okay, 24 hour, and again one minute. It should be multiplied by 36, 3600, and it will give volume. Okay, so 500 plus 520 plus 546 equal to, into 24 into 3600, it will be equal to 13,53,000. Okay, 204 2400, 13,53,000 2,400. Okay, meter cube. Okay, why we multiplied by 3600? Okay, 24 will be the total number of hours in a day, and 3600 will be the total number of seconds, okay, in a hour. So we now have volume of water available on these 3 days, okay, and now we will calculate volume of water required, okay, actual volume of water required, okay. Obviously on these 3 days, okay, 713, okay, which is average volume, average discharge should be there, okay. Therefore volume of water that should available, okay, will be equal to 713, okay, and this will be required for 3 days, okay, 713 plus 713 plus 713, okay, into 24 into 3600, 713 into 3, okay, 3 times we have to take, into 24 into 3600, which is equal to 18 lakh for, sorry, 18 crore 48 lakh 9600, 18 crore 48 lakh 9600 meter cube, okay. So the scarcity will be equal to, okay, means what, how much water is uh, less, okay, scarcity of water, okay, and that should be provided by the poundage, okay, means what, scarcity of water is equal to poundage required, okay. Therefore poundage required will be, okay, the difference between these two numbers, okay, or we can write like this, okay, because these two numbers are common, okay, in these two cases, okay. So we have to subtract 3 times 713, okay, and from this quantity 500 plus 520 plus 546 should be subtract from 3 times 713, okay, minus 500 minus 520 minus 546 will be equal to 573, 573 into 24 into 3600, okay, will be equal to 573 into 24 into 36, 4,95,072, 4,95,072 into 10 raised to 2 will be equal to 495.072 into 10 raised to 5 will be equal to 495 into 10 raised to 5, okay. In paper book it is given like that, okay. So how they have converted, I have shown here. So poundage required we have calculated. This is the poundage required. The poundage required will be the difference between average requirement of water minus actual requirement available, actual water available. Third quantity they asked for installed capacity of proposed plant. Installed capacity, okay. And for that, we can use the formula of load factor. Okay? Load factor is equal to average demand by maximum demand. Okay, this is the formula of load factor, or we can write it as average demand means what? Actual output power, average of actual output power divided by, okay, maximum demand means what? Maximum demand will be equal to installed capacity. Okay, this is what, using the formula of load factor we can calculate installed capacity once we calculate output power. And for output power we can use the formula eta overall. Okay, they have given eta overall is equal to output. Ajay, please take the snapshot of presenting. Less than 1 minute is there. Output power divided by input power.
Yes, sir.
Okay. Here they have given discharge. Okay, means what? Whenever the discharge or runoff is given, we are going to calculate power. Okay. So here we are calculating the power, input power, and using the value of efficiency given, we can calculate output power. Once you calculate output power using the formula of load factor, we can calculate installed capacity. Okay, this part we have covered in earlier lectures. Okay, so we will stop